Um, all right, momentum. There's a few new things about momentum. Momentum is similar to energy. There are two situations, or momentum is conserved, or there is an external force causing a change in momentum for your system. So in this, how do I say this? You know what, let's talk first about conservation of energy, or conservation of momentum. So there are 4 different types of systems that we're going to see. So the first system is going to be when you have 2 objects, they are apart before they collide, and then they are apart after they collide. Your conservation of momentum statement would be m1 v1 plus m2 v2 is equal to m1 v1 plus m2 v2. An example of this would be billiard balls. You hit your cue ball into another ball, and they both are moving separately before they collide and then separately after they collide. Another situation is a pushback situation. So in a pushback situation, they're going to be together before, and they are going to be apart after. Some examples of this are if you have, if you're holding a ball and you throw the ball forward and you move backwards, or if you shoot a rifle and the rifle has a kickback and the bullet moves in the forward direction. So in this case, your equation would look like this. Most of the examples for this type of situation, you're going to be moving, one will be moving forward and one will be moving backwards after the collision, or you can also call this an explosion scenario, and but not always. So you have to make sure that you're keeping an eye on your direction for your objects. Also, the word problem will give you some context clues as to the direction of the objects after the explosion. All right, and then another example is going to be if they are apart before and then they come together after. So if they are apart before, an example of this would be like catching a football, and a football player, right, you pass the football player catches it, they both move forward together. So in this case, we would say that their mass and velocity are, apart before, and then they're going to combine and move with one velocity after. Okay. I said there was 4. There are 3. Yeah, there are 2 styles like this. So when talking about energy, the reason we should talk about energy when we're doing this, and I guess I should have thought about this more before making this, I just decided to go for it. With this scenario here, when your 2 objects are apart before and apart after, this can be an example of an elastic collision or an inelastic collision. So elastic is when your kinetic energy is conserved. Inelastic is when your kinetic energy is not conserved. This first scenario is the only scenario that could be elastic. This one could be elastic. This one is always going to be inelastic. This one will always be inelastic. And you do see some scenarios where this can also be inelastic. For scenarios like this, where there's an explosion, it's normally these are at rest before the explosion, and then they're moving with some velocity after. So your kinetic energy for this particular one will most likely increase. And then for this one, you're going to be with a lower velocity after because you have a higher mass. And in general, your conservation of energy here, you're going to be having more kinetic energy to begin with and less to end with. All right. How your graphs are going to be, or your primary graph for momentum is a force time graph. And of course, force times time, your base times height, is going to give you your change in momentum. So if you have a force time graph, the area under the curve will be your change in momentum. So if you're given an initial velocity and asked to find your final velocity, you would write a conservation of momentum statement and find your velocity after your time. For momentum for systems, they trick you. So momentum is always conserved in every situation, no matter what. But they might ask you about one object within a system. So is the question asking conservation of the whole system, or conservation, or just one item? Or are they asking about one object within the system? So when you're talking about conservation of momentum, the system's momentum is conserved. So each individual object, for example, for this one, when you have objects that are stationary to begin with, and then they're not always stationary for this situation, but in an example where they are stationary and then they are moving away from each other, right? They both have a change in momentum. You're starting from one velocity and you're going to a different velocity. So each individual object will have a change in momentum, but the system as a whole will have conservation of momentum. So the biggest thing is, because of conservation of momentum here, each object is going to change momentum by the same amount. So you can evaluate one of the objects' change in momentum. So one object will have the same change in momentum as the other object. So when you're asked to rank change in momentum of systems and you're not really sure how to do this, you just take a look at how the momentum changes for one of the objects, because the other one will have a change in momentum that is equal to that, because your system as a whole will have momentum that is conserved.